Today I'm going to be talking about the new no-code indexing feature in App.build. This is a product that lets you create indexing for App.dos contracts without having to write any code or run any infrastructure. So this is going to be a rather long talk. So in the video description, there will be timestamps so you can jump around to wherever you want to go. There will also be a bunch of links at the bottom that have additional resources and links to some of the stuff that I show you here. So this is a demo. I'm going to demonstrate how you can use the platform to index. To facilitate that, we're going to go through and build indexing for the Hong Bao experience. In case you're not familiar with Hong Bao, I'll do a brief demo of how all of that works. And once we've looked at it, we'll kind of look at what API we need to power that experience. We will then dive down into the stack and look at our move contract and see what contract events we have, and then essentially figure out, okay, how do we bridge this gap between the contract and then reading the information that we care about for something fairly complicated. To that end, we will do a brief indexing 101, and then finally build the indexer with App.build, configure the API with the Hasura we provide for you, and query the API. Then to finally wrap up, we'll go over some next steps and talk about some extra resources that you can get into. So without further ado, let's demonstrate Hong Bao. So this is App.dos Connect. This is our keyless account management system where you can sign in with a social login. You'll notice that here we have this little app section and you can check out Hong Bao. So Hong Bao lets you go in and say, let's say I want to create a Hong Bao with one APT in it. So this is like one big gift that you can then break up into, in this case, let's say 5 envelopes. So when people click on the link, if there are any left, they will be able to snatch or claim one of these envelopes and get a random amount of funds between 0 and 1 APT. Then we can just say a note, Happy New Year, friends, and generate Hong Bao. Great, so this was sort of the right side. I've gone ahead and I've created my Hong Bao. Now what, right? So if I go to this link and click here, our UI needs to, based on the location of the gift, needs to be able to query information about it, such as how much is in it, how much was originally in it, versus how much remains, how many envelopes were left versus how many remain, and also like a leaderboard for when people have claimed the Hong Bao, you can see a leaderboard of who got how much. Furthermore, as a Hong Bao creator, I want to be able to see, okay, where are all of the Hong Bao I've created? And we let you do things like if the Hong Bao has been active for more than, in this case, 48 hours, you can reclaim your money back if there's still some left in there. So with that in mind, let's think about, what kind of API do we need to actually power this experience? So first off, we need let's say, we're sort of imagining these as like DB tables that you can query. In particular, this will be represented with GraphQL. So we have a gifts entity. So we have things such as the gift address. This is probably what we will query by. So it would be give me the gift with this gift address, which is just an object address on chain. And then there's a variety of other information like the creator, what coin type it is or FA type it is, how much was originally in it, how much was left, how many envelopes were originally there and how many are left, and then some other information. We also want a table for claims. So this has less information in it. It's essentially every time someone claims, we want there to be a row saying for this particular gift, have one row per gift and per recipient. That includes information about how much was snatched, right? And when it was snatched. So why do we need indexing for this? Couldn't we maybe just query the Node API, or potentially we could do this with view functions or something? We want to access information that we don't really want to store on chain. For example, when someone snatches, we don't really want to store when they snatched or how much they snatched. The only thing we care about on chain is just recording who has snatched so far, because we only let people claim once. You might think, okay, well, if we're emitting events, maybe I can just query the events table. I could collapse all of the information in that table and get like the current state based on that. This is sort of a common foot gun. Like it works at first in some cases, but once you scale up, these queries become very inefficient because you might have, thousands, hundreds of thousands or millions of events, and it's just infeasible to aggregate a query across all of those. Some on-chain information is very difficult to read without indexing. So like we use a smart table, for example, to keep track of, who has claimed from a gift. These are very difficult to read using the Node API. And finally, we want to query data that's no longer on-chain. So when you reclaim a gift, to be as cheap as possible, we actually delete all of the information about the gift on chain. So we delete the object, we delete the table and everything related to it, and the caller gets a gas refund. So that information is not even on chain anymore, and this is where indexing can come in handy. So we know we need to index. How do we do this? Normally you would have to go in and write some code. This part's not so bad anymore because we have the SDK, the indexing SDK, that makes it easier to write processes. The trickier part is that you need to run infrastructure. So once you've written your processor, you now need a database, a processor, process, an API, and all of the things that come with the API, like SSL and domains and all of that. You need a continuous integration system and testing and monitoring and all of that. There's a lot that comes with running infrastructure. So we have solutions to this. So with no-code indexing, you get a UI-based configuration system instead of having to write any code. And we will run the infrastructure for you as part of app.build. So a very quick indexing 101, we sort of think about two different kinds of tables. There are activities tables. So generally this is one row per activity. Think about something like coin or fungible asset transfers. Every time there's a transfer, that will be a row in a table, maybe with the sender and recipient and the amount and the coin type. Generally, this means there's no primary key. It's just there's one row per activity. And rows are generally not updated. It's like a one and done thing, and then that's it. Current state tables, on the other hand, it's sort of one row per entity. So you can imagine something like account balance. Every time some sort of like coin-related activity happens, we also want to update the account balance in this table. So usually they have a primary key. In this case, it might be the account address, and then the value that we update is the account balance. So the rows are often updated in this way. In our case, claims are an activity. So every time there is a claim, this is a new row in the table, whereas gifts have things that we want to update every time. So when someone snatches, we want to change the value for the amount of APT or the amount of asset remaining and the amount of envelopes remaining. And some queries we might want to do for claims is, get me all the claims by this account, or get me all the claims for this particular gift, maybe sorted by claim size, or only if they're newer than a certain time. And then gifts, it might be get all gifts created by account X, and you can select particular fields that you care about, and again, like a variety of filtering options. So how do we do this with app.build? So here in the Explorer, this is the Explorer page for the module where Hong Bao is deployed. We've got a few events that we emit in our contract. So you can see here that we have gift address. So when a gift is created, we emit this create gift event, and we emit a variety of information about it, such as like where the address is on chain, who created it, the original number of envelopes, which coin type is stored in there, or if it's a fungible asset, which address it is for the asset, the amount, message, things like that. When an envelope is claimed, we also emit information similar to what we saw before with claims, like the gift, the recipient, and how much they claimed or snatched. And finally, when someone reclaims a gift, where they sort of take back whatever was left in it, if there is any, and clean up all of the state on chain, we emit one of these events as well. Let's go to app.build and build an indexer for this contract. So to start with, you're presented with the front screen of app.build. So you go in, select a project, and then you click this processor button to build a no-code indexing processor and API. So let's name it Hong Bao Mainnet 2025, for example, mainnet, and then you choose a version that you want to start indexing from. So normally you would select the version that your module was deployed at, but in this case, we'll just use the latest version of mainnet. So here you're presented with this canvas, and this is where you configure the way that your processor should work. So the two key concepts are there's data sources and data destinations. A data source is primarily an event. So this is, when transactions happen on chain. When they emit events, the processor will process those events and do something with them based on the mapping we configure here. And then there are data destinations, which is in this case just database tables. So we'll start with the data source. So first you paste in the address of the module that you want to index. And then from here you can see, okay, here's this Hong Bao module. I want to index create gift event. So when it does that, it loads in this sort of box that you can drag around. Now, what we said earlier is that we want a gifts table. So let me just write a few of those things in. So we'll have a gifts table with a gift address column, a creator address column, and let's say an amount column for now. So to configure the way that the events map to tables, it's very easy. You just drag lines like this, creator, amount. Now over here, recall earlier that we wanted this to be a current state table. So for that, we want there to be a primary key generally. So gift address is the primary key. So what this essentially means is whenever we see an event related to a particular gift, instead of inserting a new row for that gift address, we will update an existing row, right? So this will be more clear if I bring in the other event type. So let's just grab this again. Let's go claim envelope event. So at first, with this create gift event, we have, let's say actually original amount, and then we have remaining amount. So original amount is just the amount of asset, let's say APT, that was originally in the gift. Remaining amount is how much is left. So at first, when we see a create gift event, we will create a new row in the gifts table where original amount is based on amount and remaining amount is also based on amount. Now, when we see a claim envelope event, based on the gift address, there will be an existing row, and then we will go in and we will update the remaining amount based on the value in this claim envelope event. So in every claim envelope event, we emit this remaining amount value, which has the remaining amount of the asset remaining in the gift. So yeah, so just to summarize, at first, remaining amount is populated from amount in create gift event, and later on it is updated based on remaining amount in claim envelope event. And the reason why this updating behavior works instead of inserting a new row is because of this gift address primary key, right? Now you can see here that you can add indices on other things. Like let's say we want it to be efficient to query on creator address, we add an index there. Whereas these things, maybe we don't want an index. We're probably not filtering based on these values. We will just read them. Yeah, and that's generally the principle of how you do it. So I've already gone ahead and configured all of this here. So this is what it looks like when it's finally done. So we have our create gift event, claim envelope event, and reclaim gift event. We also have transaction metadata. For example, like when a gift is created, we care when it was created at and what version it was created at. Let's just zoom out, reorder these. Yeah, and you can see here that we've got this primary key on gift address. Now, once this is all configured and you're sort of ready to roll, you can go ahead and review this config. This YAML probably won't mean much to you, but we do support exporting and importing YAML configs so that you can more easily manage your processors. But yeah, once that's all done, you can just go in and go create processor. You get a final opportunity to review, and then we go create. Now, this talks to the no-code indexing platform and essentially says, okay, please provision all of the infrastructure for this processor. And here we get to see some information about it. So you can see that already we've created the database for this. All of the databases for each processors are isolated from each other. We will spin up a processor. You can see that that's now running. And you can see some information like when this is like the actual current version of mainnet, and this is where we've indexed up to. So for this example, I actually started it from the version where we deployed the contract. This way you can see whether your indexer has, caught up to the latest state of the chain or not. The final piece of infrastructure we provision for you is an API. These two pieces, the processor and the database alone, just do the indexing, but you need to be able to query it. So this one will take a little bit longer. I'm going to pause here and then I'll come back in a couple of minutes once this API is provisioned. Hello, we're back. So you can see that the API is up now and it's routable. So from here we get given two URLs. What we do under the hood for you is we spin up a managed version of Hasura, which is a way that you can run a GraphQL API on top of a database. So you want to take this Hasura admin secret and go to the console. So from here, you just copy in your admin secret. And at this point, you can go in and configure your processor. So to start with, we start you off with some sort of base metadata that will connect Hasura to the database, and you can query certain things like the processor status. So, remove that. So you can see here we can query the status of the processor. So this is the version of it's processed up to. If we run it again, we will see that this is advancing, indicating that the indexer is successfully indexing. Now, what we want to do from here is go in and configure the data. So below the video, I will include some resources for how to sort of get started with Hasura. But at a basic level, all we really need to do here is go in, ignore all of these G underscore tables, but we'll go in and track envelopes and track GIFs. So this sort of exposes these to the public. You need to go in also and declare which fields you want to be queryable. So you're logged in as admin, but when anyone's querying, they sort of count as this anonymous role. So you can say, allow them to select without any checks and let them query all of these fields. Maybe you want to hide some of these fields. You only wanted them for admin purposes or something. Save permissions. And now we go to GIFs and we do the same thing. Okay, so now we should be able to go here and see that these tables that we configured are now available, envelopes and GIFs. So let's say I want to go in and query some GIFs. I want to see the creator, the coin type or fungible asset metadata address, depending on which was used for the asset, and how much was originally in the gift. And we query that. And then bingo, here it all is. So from there, you can even go in and say, okay, actually, I only want GIFs created by this particular creator. So we can say where creator address equals this address. And now we only see GIFs created by that person. And because this is GraphQL, you can essentially go in and slice this up however you wish. Generally speaking, you should only be filtering based on fields that you put an index on for performance reasons. But yeah, you can really do whatever you want. And depending on how you've configured it, you can also do aggregate queries, like, get me the sum of APT that a particular person has claimed across all GIFs, something like that. That's all expressible. So here we have this configured in the console. How do I actually query this from the outside world? So if we go back to our processor, we see here that was the console URL. We also have this API URL, right? What we need to query that is an API key. So we can go to keys and then find our thing, test Hong Bao mainnet, and then we have an API key here. We can copy that. Later on, we'll also have some snippets here that you can use, particularly for your no-code indexer. Now, here's a little example I prepared earlier. So here's a query that we just made before. This is what it really looks like. And then here's a curl command we can make. So this is that API key we just grabbed. And this is that API URL that we just got from the platform. So if we run that, type into JQ, bingo, we get the data back from the API. And that's it. From here, you have an API that you can use, powered by indexing that you didn't have to write any code for, and you don't have to run any infrastructure for it. We handle all of that for you. Yeah, so that's the end of the demo. From here, there are other things you can do. You could go in and, generally speaking, you want to create some kind of like code gen system for your clients. So, you have GraphQL queries with maybe parameterized variables. You can then generate code so you can use those in your clients. Below the video, I'll include links for how to get into that. I'll include some links on how to learn about Hasura, some links to the docs, and I'll also include links to the source code that we use for this demo for Hong Bao. Yeah, that's it. Thanks for sticking around for this really long video. Hopefully this was helpful.